All right, to recap, we have two forms of linear equations that we've learned about now. We have slope-intercept, which has a wonderful descriptive name because it's all about the slope and the y-intercept. We have point-slope form. Point-slope form is a wonderfully descriptive name because it's all about the slope and a point. So we have our slope and we have a point made up of x1, y1. Now today we're going to get to the final form of linear equations, which is called standard form, which is not only not very descriptive, but also it's not really the one we use most commonly. We use slope-intercept most commonly, so you'd think it would be the standard one. But standard form is written as ax plus by is equal to c. I feel like sometimes it's also written as ax plus by minus c equals 0, but we're going to be using this first version of standard. It's what's on the star chart and it's what we teach. But if you ever are looking up problems online for standard form and you see it like this, I think that's an alternative way of writing it where you bring c over to the left, but that's whatever. So slope-intercept was great because it was about the slope and the y-intercept, and point slope was great. Both of them let us graph really easily, starting from a point that we knew, which was either the random point in point slope or the y-intercept in slope-intercept, and then we used our slope to find another point. Great. We could also read both of those off of a graph. We can also use ordered pairs to create both of those. They're both really good forms. Standard is kind of the least useful of the forms, but every now and then there are some benefits to it. So we'll talk today about what we can see and what we can't see from it, and we'll try to figure it out. To do that, we need to first talk about x and y intercepts. We talk a lot about y-intercepts, but not so much about x-intercepts until now. So my y-intercept in this graph is 0, negative 2, and my x-intercept is 1, 0. So those two together are pretty important for standard form. And you recognize x and y intercepts because in the x-intercept, the y value is 0. And in the y-intercept, the x value is 0. And then whatever the number is, that's your intercept. So let's get started on talking about how to find intercepts in different forms. So finding x and y intercepts from a table, just like I said above, we're looking for where y is 0 or where x is 0. Sometimes that's given directly. So we have negative 2, 0 for the x-intercept and 0, 4 for the y-intercept. So x-intercept is negative 2, 0, and y-intercept is 0, 4. And we should write these as ordered pairs, not just as a single number. So I would prefer we not write negative 2 and 4, but instead write the entire ordered pair for x and y intercepts. The next one, we have the x-intercept is this point at 2, 0. And the y-intercept is this point at 0, negative 3. The next one, actually, I'm going to leave the next one for you because it has both of the zeros in the table again. And then we're going to skip over to the fourth one where we don't have the 0 values in the table and we actually need to add additional values. So I can see here that if I go backwards 1 on the y value, I'm going backwards 2 on the positive 2 on the x value, and backwards 1 on y. So if I go back one more time, my y becomes 0, which is going to give me my x-intercept, and my x value, since I'm adding 2 at each step going backwards, is 12. So I find that by adding a row, or as many rows as I need to until I find the correct thing. Then going forward, if I want the x value to be 0, I'm subtracting 2 going forward. So that's one more step forward. And going forward, I'm adding 1 to the y value. So that would put me at 0, 6. So if your value is missing in the table, you follow the pattern, the rise and run pattern, to find the missing value. If we have an equation, then we basically do the opposite. Instead of looking for 0, we make something 0. So if I could show you physically, I usually like cover these up. So I'll cover it up with a marker instead. So like if I were doing this on a paper or on a screen, what I would do is to find the x-intercept, I'm literally zeroing out the y. I literally just cover that up and pretend it doesn't exist because I'm plugging in 0 for y, which makes 3y also 0, and it just kind of fades away. Then to solve for x, all I need to do is simply divide by 2. So when I divide both sides by 2, then my x-intercept is 3 because I made the y value 0. Conversely, to do the opposite thing and find the y-intercept, I'm going to cover up the x value. So pretend this doesn't exist. We just have 3y equals 6. So x is 0 and y is 2. That is the main benefit of standard form. So these equations are written in standard form, and to find the intercepts, we just plug in 0 for whichever one we're trying to find the other one of. So if I want the x-intercept, I plug in 0 for y. If I want the y-intercept, I plug in 0 for x. So here, if I want my x-intercept, I imagine this doesn't exist, divide by 3, so it's 8. Really easy to find intercepts. To find the other one, I'm going to imagine the 3 doesn't exist, divide by -4, so my y-intercept is -6. So one of the things standard form is strongest at, so standard form is good for finding intercepts. That is one of its strongest features. And the last one, since we have one x and one y, if I just cover up x or y, both of these are 3. So my x-intercept is 3, 0, my y-intercept is 0, 3, and that's that. Okay, and so finding from a graph, we literally just look like we did in the warm-up question. We look at the dots where the x and y intercept are, and we write them down. I'm going to skip that because we did the one in the warm-up, and literally you just put this here and you put this here. So a little trivially easy on that. But what may not, well, hopefully it's obvious how we do it, but what may not be quite so obvious is how we graph using the intercepts. So both of our other forms, we graphed a single dot, a point, and then we used the slope to locate an additional point. When we graph in standard form, it's completely different. So in standard form, we graph with the intercepts. Intercepts. So we plot the two intercepts. If I cover up the y, my x-intercept is 6. If I cover up the x, my y-intercept is 4. So I plot those two dots, and we know that once we have 2 points, there's only a single line that can connect those points. So I'm going to make my ruler, and I'm going to slant it. And when we connect these two dots, that's the only possible line to connect them. So we actually graphed without finding the slope, which feels kind of weird because we're used to finding the slope as like the first thing that we do. Now we could use our graph to find the slope. I have a rise of -4 and a run of 6, so my slope is -2/3. But if all it's asking for me is to graph from the two intercepts, I don't need to know the slope. I made the line, I did the graph, and I never needed the slope to do it. So this method feels quite different than the other ways we've done it. All right, next one. If I cover up, well, we have 1, 1, 2. Let's go 1, 2, 3 instead. That makes me feel better. Okay, if I cover up the y, my x-intercept is 2, so I have 2, 0. If I cover up the x and divide by -2, my y-intercept is -5, so that'll be between -4 and -6 down here. And then again, I would connect those with a line. I could now find my slope on my graph here, and I would have that. So now we have our 2 dots. We would get our ruler, draw the line, and then on the last one, we would cover up the -y. So my x-intercept is at 4, and my y-intercept, if I cover up the x, I need to divide by -1 because I have -y. So my y-intercept will be at -4. So I would get my ruler, draw my line. That one's actually not that bad for not using a ruler. That one's worse. Yep, that's pretty bad. But use the ruler. Ruler's good. So that's how we can graph from standard form rather than switching it into slope-intercept form and then graphing, which is what we did before. So if we gave you an equation like this back 2, 3, 4 weeks ago, the first thing you would have had to do is rearrange it into slope-intercept form. So you would have subtracted 2x and get, that's a bad 3. 3y equals -2x plus 12. Divide by 3, get y equals -2/3 x plus 4. And then you would have graphed using this and this, the slope, the y-intercept and the slope, and you would have gotten the exact same graph, but you had to do a lot more work to get there. Being able to graph directly from the intercepts gets us to the graph faster. So it is a very useful thing to have this standard form sometimes. But if we don't want standard form, we can always go and turn it into into slope-intercept form. So we can kind of think of standard form. We just have to be given that form, and then we can. I'm going to try to write a diagram of this. So if we are given standard form, we have 2 options. We can turn it into slope-intercept, or we can turn it into a graph, graphing it by its intercepts. If we are given a graph, then we can either write the slope-intercept equation using the y-intercept and a point, or we can graph the point-slope equation using the slope and a point. What we don't have the ability to do easily, and would be way more trouble than it's worth, is to try to write standard form from a graph. If you're given a graph, you want to write either slope-intercept or point-slope, not try to write standard. Keep in mind, though, that we can always, so if we have point-slope, we can convert that into either slope-intercept by distributing and rearranging our terms, or we can convert it into standard by distributing and rearranging our terms. And let's draw arrows. We can pretty easily convert slope-intercept into standard. I think we're going to do that down below. But we can't really convert things to point-slope form unless we're given a point to use, because there's infinite ways to write that depending on which point we select. So it's kind of like a starting point for writing equations, just like a graph is a starting point for writing equations. Hopefully that kind of gives you a perspective as to how these things are used. So if we have standard form, we can graph it or turn it into slope-intercept. We can also turn slope-intercept back into standard. All right, let's keep going. So we have a problem that doesn't count by ones. Oh, it does count by ones. There's intermediate lines. Okay, anyways, let's do this. So it has number of songs downloaded and gift card balance. So I don't see a prompt for the problem, but it appears that we have somebody who has a gift card and they're using it to buy some songs and their balance is going down. Every song they buy, they went from $20 to $16 to $12, so they're spending $4 on every song. Our x-intercept is 50. And then what it represents, remember we mean like in words in terms of this picture, this problem, it represents the maximum number of songs you can buy. Because once we buy 5 songs, we have $0 left. We can't buy any more. The y-intercept of 0.20 represents our starting balance, or starting gift card balance. So our x-intercept typically represents a maximum or minimum amount of something, whereas a y-intercept represents an initial value or a starting value. Can I determine the cost per song? Yes, I did that before they even asked us. It costs $4 per song. How would I determine the cost per song from the graph? Oh, we did that. We went down $4 and we bought 1 song. So that was -4 and 1. Now I wrote the cost as $4 per song because cost is taking away money. And so yeah, even though our slope of our balance, the amount of money we have, is going down by 4, then the cost of the song is +4 because each 4 we buy is taking away from our balance. If we wrote the equation, our balance, the amount of money in the gift card, would be y equals -4x plus 20 because the cost of 4 is subtracting from our balance. Money can be tricky sometimes as to what's positive and what's negative, and here we see that the 4 is a positive cost, but a negative hit on our balance. All right, standard form, ax plus by equals c. There are 3 rules to standard form. There are 2 of them here, but I'm going to add a third one that we don't really worry too much about, but it is technically a third rule. The first rule is that a, b, and c have to be integers. They cannot be fractions or decimals. If you don't remember integers is a really important math vocabulary. It means all of the numbers on the number line that are positive or negative or 0. So as we go along the number line, we have 1, 2, 3, 0, -1, -2, and so on. So it's all of these numbers that are like our main counting numbers, but nothing in between them. So there's no 1.1 or 1.5 or anything like that. So integers are all the positive and negative whole numbers is a way we describe it. So a, b, and c must be integers, meaning if they are fractions, for example, a slope, we need to multiply by a denominator across the board to make everything into whole numbers or not fractions. Second rule is a is not allowed to be negative in linear standard form. So this number has to be positive. If it's negative, we can fix it by multiplying all the terms by -1. Very similar to when we end up with -y equals x plus 4. We correct that in slope-intercept by multiplying or dividing each term by -1, and it switches all of our signs. So we get -x minus 4. So same thing for standard form. If our first term is negative, we're just going to switch all 3 signs. So switch all signs if needed. The last one is kind of nitpicky, and we won't worry much about it. But if you think about a standard form equation, let's say x plus 2y is equal to 3. If I wrote a different equation, 2x plus 4y is equal to 6. this would be the exact same line, but all of these numbers are bigger because I could divide them all by 2 and shrink it down. So the third rule is if all three terms can be divided by something, you're supposed to simplify it, kind of like how we simplify fractions. So 2, 4, and 6 are all divisible by 2, so this is the proper way to write that one, not with the bigger coefficients and constant that could be reduced and made smaller. Generally, unless you multiply a fraction by too big of a number, you don't have to worry about that. But I'll show you an example when we get down here. All right, so x goes first, then y, and then the constant goes on the other side. And like it says here, if the leading term, that's the one in front, the one with the x, is negative, then we multiply everything by -1. So let's do some examples working with these so we can try to see how they work. First, we have y equals 8x minus 7. I need the x and y together, so I think the most normal way of doing that is to subtract 8x. I should zoom in too. Zoom. All right. We subtract 8x, and then when I rewrite it, I have negative 8x plus y is equal to -7. Now I check my conditions. So all of my coefficients, a, b, and c, are integers. I have -8, +1, and -7. So that's good. The first rule is satisfied. But the second rule says this 8x can't be negative. So we're going to multiply all this by -1, which just switches all three signs. So I get 8x minus y is equal to +7. And that is my standard form for that equation. I'm going to go to the side. I don't know why. I'm going to go to number 4 because that feels like it should be number 2. So this one has fractions, and it's already almost in standard form. We have the x and the y together. The 3's over here. The leading coefficient is positive. That's all great stuff. The one problem is we have fractions, and we need all of our a, b, and c to be integers. So here's where we want to multiply by something to get rid of all the fractions. And when we do that, we want to find the least common multiple, the smallest number we can multiply by to get rid of all fractions. So here, I have a denominator of 4 and of 2. So I could multiply everything by 4 times 2, which is 8. But I'm going to do this. It's wrong, but I'm going to do this just so we can see. So if I multiply everything by 8, 8 times 1/4 x is the same as 8 divided by 4, so that's 2x. 8 times 1/2 y, that's 1/2 of 8, so 4y. And then 8 times 3 is 24. So this looks like a standard form equation, but all of these are divisible by 2. Meaning that it doesn't meet that third requirement that it can be simplified. So instead of multiplying by 8, we should have multiplied by the smallest number that 4 and 2 both divide into, which is 4. So that would instead give us, I'm going to go ahead and rewrite it then, now that we understand. So multiplying by 4 instead of 8 will mean we get the best answer. 1/4 of 4 is 1, so I just have x, plus 1/2 of 4 is 2, y, and then 4 times 3 is 12 on this side. So that's the same thing that I would have gotten on the first go-round if I divided everything by 2. So basically, by multiplying by 8, I kind of doubled the size of what everything was supposed to be. All right, now we'll go back to number 2. Number 2 has 2 problems. The x is on the wrong side, and there's a fraction. So we're going to fix those. I'm going to fix the side first. So I'm going to subtract 1/2 x and subtract 1/2 x. You could multiply everything by 2 first if you want. Just remember all 3 things get multiplied by 2. So now I have negative 1/2 x plus y is equal to 3. So I fixed one problem, which is x is now with y, which is good. But we introduced another problem, which is that now x is negative, and that's not good. So next is we multiply everything by 2 to get rid of the half, but while we're at it, we're just going to multiply everything by negative 2. That will take care of the sign and the denominator. Negative 2 times negative a half cancels, so we just get x. Negative 2 times y is minus 2y, and 3 times negative 2 is negative 6. For number 5, it says y equals 3. So there's no x's. It's just a horizontal line at 3, which means it doesn't matter. Like, I don't have to do what I did in 1 and 3 and move the x's from this side to this side because there are no x's. So this is actually already standard form. So this is the slope-intercept form, of course, but it's also the standard form for this one. So when we have a horizontal line, standard form and slope-intercept form are exactly the same. The next one has distribution, so this one starts in point-slope form. We need to distribute, so we get y minus 12 equals negative, that was a bad negative, negative 2x minus 2. Now we're going to put our like terms together, but we have to decide, are we going to slope-intercept form? If we are, we would bring the 12 over here. But if we're going to standard form, we actually want to bring the x's over with the y. So we're going to do that. And then the 12 needs to go to the right. So we're going to add 12 and add 12. So I guess we needed to add 12 either way. So now I have 2x plus y, the 12's cancel, equals, the 2's cancel, or the x's cancel, and negative 2 plus 12 is 10. So we get 2x plus y equals 10, and that's our standard form. This one, x is on one side, constants on the other side, and there is no y value, so this is a vertical line, and this is already in standard form. Technically, it's not slope-intercept form because there's no y value at all, but we would write it the same if we were asked to write it in slope-intercept form because this is as close as we can get. Let's see, I was seeing if there's a certain problem here. I don't see it, so we're going to go and talk a little bit more about 5 and 6. So we have y equals 3, and if it's not clear how that's standard form, think of this as 0x plus 1y equals 3. So if we were asked to identify the values of a, b, and c, we would say a is 0, b is 1, and c is 3. And I didn't mention earlier, but I apologize on behalf of math that we're using b again, when b is used to being the y-intercept. As a consolation prize, at least we're capitalizing this one, so it doesn't look the same as the y-intercept b. But yeah, it's kind of annoying. All right, the same thing for the x equals. You could think of this as 1x plus 0y is equal to negative 2. So in this one, a is equal to 1, b is equal to 0, and c is equal to negative 2. So yeah, right. Write an equation that represents these. It looks like we're a little too zoomed. All right. Tank is being filled with gas at a rate of 4.5 gallons per minute. So our slope, 4.5, is the same as 9/2, but we can write it as a decimal. That's fine. The gas tank contained 1.5 gallons before filling started. So our y equals 4.5x plus 1.5. If you're more comfortable writing that as 9/2 and 3/2, you can certainly do that. But to fix this, first we need to subtract 4.5x from both sides. I don't really have a lot of room, so I'm just going to not show the in-between step. Plus y equals 1.5. And then we need to multiply everything by something that gets rid of the negative and something that gets rid of halves. So here's a spot where we might accidentally make the numbers too big, because we know that we can get rid of decimals by multiplying by 10. But that would make these numbers way too big, because since these are halves, we want to multiply by 2, not by 10. So when I multiply negative 2 by negative 9 halves, I get 9x minus 2y is equal to negative 3. So that's my standard form equation. If you multiplied it by 10, then you would have ended up with like negative 45x minus 10y equals negative 15. And then hopefully you would notice that all of these numbers, a, b, and c, are divisible by 5. So, I guess I mixed up my signs, so we'll say that's positive. So all of those are divisible by 5, so then I should divide them all and shrink it down to its most reduced form. I'm going to skip that one. I'll leave that one for you to do. And then slope-intercept convert from standard to slope-intercept, yeah. So standard to slope-intercept is just the reverse of the steps we just did. So has method 1, method 2. I don't want to graph this. I'm not gonna. I'm just gonna do it without graphing because we don't need to graph. And this video is already really long. So we have 3x plus 5y equals 15. If we want to convert this to slope-intercept, we already have practiced this weeks ago. We move the x's to the other side, so minus 3x. Then we have 5y equals negative 3x plus 15. And then we divide each term by 5 and end up with y is equal to negative 3/5 x plus 3. We can also find the equation by graphing. We have to be very careful, though, that we graph it perfectly because we're going to be counting the slope from the graph. We can also count the slope directly from the x-intercept to the y-intercept and find the slope that way. How much more do we have here? Yes, that's the end. So that's the end of the note page. I'm going to talk about two other things that standard form is good for that are a little more advanced. So if you feel overwhelmed already and want to come back and look at this later, I understand. If you feel like you don't want to look at it at all, I understand. It's all right. So we're going to look at standard form ax plus by equals c. And think about if I needed to get the slope or the y-intercept from this equation, I would rearrange it like we just did, but I'm going to do it with letters this time. So I'm going to move the ax to the other side, and we get by is equal to negative ax plus c. Then I need to divide by b on all three terms. So we get y equals negative a over b times x plus c over b. This is a shortcut that's not incredibly useful yet. Give me a minute, I'll get there. It's not incredibly useful because that's really easy to do. Like when I had to rearrange the slope-intercept equation over here, that wasn't difficult. I can just do that. But this is a shortcut that tells us that our slope is negative a over b, and our y-intercept is c over b. So in theory, we can go directly from standard form to knowing what the slope and y-intercept are without actually doing the algebraic steps. We know that the slope will always be negative a over b, and the y-intercept will be c over b. Like I said, not that valuable, but it leads us to the thing that is kind of valuable, which is the knowledge that the slope only relies on a and b, meaning that c doesn't matter when determining what the slope is. So if I look at two standard form equations, like 3x plus 2y is equal to 7, and 3x plus 2y is equal to 81. I can tell, because A and B match, that these are parallel. Without doing any work, without rearranging it, and without graphing it, because A and B are the same, so this 3, 2 matches this 3, 2, I know these two equations have the same slope and a different y-intercept because they have a different number on the right side. So this is actually a pretty big time save, and it's something you might see on a test or on STAR where it gives you equations and asks you which ones are parallel. And they expect you to rearrange it into slope-intercept form and find the slope, which is totally valid. You can do that. But if you understand this at a deeper level, like this, then that's a nice shortcut to mentally knowing those are parallel right away. The next one is if I had something like 2x minus 5y equals 8, and 5x, is it minus, plus 2y equals 17. Then again, I know that I'm only relying on A and B to get my slope. So by swapping A and B, that's the same thing as making a reciprocal. And by switching negative to positive, that's an opposite. And we learned before that opposite reciprocal slopes are perpendicular. P-E-R-P-E-N-D-I-C-U-L-A-R. So if you see that the slope, or the A and B, switch places and this sign changes, then we know that those are perpendicular lines without ever having to graph them or rearrange them into slope-intercept form. So those are some advanced shortcuts you can use if you understand this at a higher level. If not, then you always can go back to the normal way of doing it and the way this test expects you to, which is to manually rearrange each equation. So that's where we'll wrap up on our standard form and intercepts notes. I know it was kind of long, but it's a lot of stuff we need to know about. It's a whole form.